Hey folks, welcome back and welcome to the Instagram folks watching on Instagram Live. I'm going to cut you off in about 2 seconds. So if you want to watch, jump on Twitch or YouTube or Facebook or Twitter and join in. For the rest of you, welcome back. This is another uplifting Twitch stream about collab skills and all those good things that you should know. Today, we are going to be joined by Charlie, someone I've chatted with a number of times and is a listener of the podcast. And one thing I am not good at is technology. Just ask anyone that's been on our Twitch, and they have a question. I'm like, I don't know how to fix that. So today, we're going to listen to some of the things we can do to make some simple, replicable technology that can help us in the garden. So for me, I have a grow 10. I also have like baby chickens right now this time of year. Having them on a space, if they're in like a basement and you want them to get light like seasonally or like, daytime, nighttime, having access to something like a basic way to go through that process is something I think is really important. And right now I rely on cheap Chinese knockoffs. So I'd like to know how to do some of this stuff myself, and I'm sure I'm not the only one. So, Charlie, thanks for coming on.
Of course, yeah. What you were mentioning just a second ago, I think, is a really vital point that a lot of people don't think about, which is we spend so much time interacting with electronics every day, and each piece of electronic device thing that we work with is something that was manufactured and sold to us. We don't know what's inside of it. We don't know what it's doing. And if it breaks or if we can't get that specific thing, we're sort of up the creek. We don't know what to do. And so, what I really like to highlight in talking to people about electronics is that it's not that complicated. People have been trying to convince you it's complicated for a very long time. It's it's not difficult. It sometimes just requires being open to burning things a few times, having something melt. And if you're already working with stuff that maybe you get off the street, it's not a big deal if you melt something. So,
Awesome.
with that in mind, I would love to talk a little bit about Arduinos. Um, So, oftentimes, if we're talking about something like what you were just talking about with lights turning on and off for your chickens, you and I spoke briefly, and you mentioned that it's a smart switch that you use. So,
Yep.
how do you use that?
So you buy it from the store and you download an app. And when you plug it in, you connect it to your Wi Fi. And in that process, you usually do like you connect to it as your Wi Fi, and then you can switch it to your Bluetooth. Or you make it a device, I guess, on your Internet of Things. And that gives you access to basically set timers and things like that.
Yeah. So, with that in mind, it sounds like the use case you're talking about is you want to be able to have your lights turn on and off with a timer. And the easiest way to do that was to go to the store and get a smart switch. Inside of that, what you described, it sounds like there's probably a computer chip that's responding to stuff and running stuff. There's a little communications chip that's sending stuff over Wi-Fi or Bluetooth, and then there's a whole bunch of stuff on the internet that's communicating back and forth and figuring everything out. Realistically, a lot of that we can either make ourselves, we can buy very, very cheap, and we can just decide what parts of those things we don't even care about or want at all. So in the case of a smart switch, if I just need a timer, I don't really care if there's an app involved. I don't care if I have to use the internet. Realistically, I just want the thing to turn on and off at a time that I expect. So instead of buying a smart switch, you can buy something that you can use again and again. So this is a little Arduino board. They're pretty small. You can get them a bit more, you can get them bigger, you can get them smaller. You should never pay more than $30 for one of these. You can get ones that have other features on it. So this is a really, really big one. And you can get other things that look a little bit different, and I'll be talking about them, but they do a lot of the same things. So for each one of these, they have a computer chip on it that you can write a program for through, you download this program from the internet called Arduino, and you can type in little programs that will run on here that you can customize exactly what you want them to do. What they're doing is they are listening for inputs, and those are things you can wire in. It could be something like a thermometer or a light sensor, anything you want to connect up. And then it connects to an output, which is the thing you want to have happen when it notices something. So for example, you could have this have a light sensor, and when it goes when it notices that there's light, it triggers a fan that turns on. So if you have a greenhouse and you want to have good ventilation during the daytime, you could easily have that input and output. In the
Yeah.
case of turning on and off lights for your chickens, you could have something very simple with this where all it does is it already has a clock in here. So you could program this for if it's within this amount of time, you want to connect those lights to turn them on. And if it's not at that time, you turn them off. It's only about 10 lines of code. Spend about $15 on this. And if you're working with not LEDs, you're working with something that connects to wall power, you might want to buy something like this, which is called a relay, which is just a way of connecting something that's low power, like an Arduino, to a high power system, like something that plugs into the wall. So you plug in your Arduino wires there, you plug in your wall wires there, you write your program, and then you have your timer switch for your lights. And if you ever want to get rid of it, you can take all those parts apart and use them on a different project. You don't have to be dependent on that one person's machine, that one app. You're totally in control of how you want this thing to work.
That's awesome. As you were talking, I was thinking about some of the other projects that are like on my to-do list, like a greenhouse and setting up like ventilation for it, or even setting up fans for like humidity sensors just to circulate air when it gets humid, especially like in a grow tent or something.
Yeah.
There's definitely, I think, a number of ways to utilize it. That's not just, um, you know, turning off and on light switches. And one
100%. Yeah. So, oh, go ahead.
I was gonna say, and someone commented there's a ton of free code online if you don't know how to code, which I don't. I took HTML in high school 20 years ago, and I'm sure all that's basically irrelevant at this point. You can copy and paste it, the stuff you can get offline from a huge community online if you have a project. It's either there or you can ask the community.
Yeah, absolutely. I glossed over a little bit for a second about the code that's written on here, just because you don't really have to know how to code. Honestly, if you just ask really nicely on Reddit, someone will probably write all of the code for you just because they want to be helpful. It's useful so that way if something's broken, you can fix it, but you can start from zero coding knowledge and you can pick this up for the sort of applications we're talking about. It gets more complicated if you want to do something like, oh yeah, I want, real time facial recognition, blah, blah, blah. Then you're going to need to know some stuff. But if it's
Yeah,
turn on and off the light, that's not complicated.
awesome.
For what you were just saying a second ago about humidity and temperature, this is an example of one input. This is just a little doodad I got on the internet. I want to say for like $15 maybe. So this is a temperature and humidity sensor. You can get this as your input. You plug it into your board, and then you can take readings of temperature and humidity and decide what you want to do with that. So if it's above a certain temperature, maybe you want to turn on a fan. If it's above a certain amount of humidity, you do something else. It's all up to you to decide how you want to be programming this and what you want to be doing with it.
Yeah, definitely. And Elliot, thanks for joining us.
How's it
Uh,
going? Sorry I'm late. Forgot to feed
uh,
my dogs like an
yeah, yeah.
asshole.
Worst dog owner ever.
Yeah, I'm not
Uh,
doing great.
so, Elliot, to get you up to speed, we've been talking a bit about what, like, how to do some basic automation using Arduino, which is apparently actually, I can't even define what Arduino is. Is it the software or is it the hardware itself?
That's a very good question. Arduino is technically a open source hardware company from Italy, I want to say. So they specifically manufacture and design these boards, and they also make software that make it very easy to write code and upload it to these boards. But
Oh,
because
cool.
it's all
Sure. Those are
open
the
source, oh, I'm sorry, go ahead.
are those the little cherry pie motherboard type deals?
That's a very good question. So
Or
Raspberry
Raspberry
Pi is
Pi, sorry.
Yeah, Raspberry Pi is something that's higher end. They'll charge you more money for it, and it's probably something you don't need.
Okay. But it's a
Raspberry
similar
Pi
similar
are
product?
miniature computers.
Right, right. Okay. So is it like a similar um like can I see it again? Because
Yeah, absolutely. Sorry.
that's what it looked like when you were holding it up. So is it
Yeah,
something
so they
similar
look
similar
really,
to
really
that?
similar.
Okay.
So this technically is something called the formal term for it is a microcontroller. So it's running a bare metal operating system where it's just running a little bit of code over and over and over again in a loop. So when you turn it on, it's like, okay, check this, check this, check this, do this, do this, do this, and then it goes back to the beginning.
Okay.
A Raspberry Pi is like an entire Windows computer that they just made really, really small and portable.
Okay, got it. So this is it fits into a specific space, and it's specifically for automation. I'm guessing like it's basically like a an overpowered timer or a regulator, some sort like that.
Yeah, well, it has, it depends on what kind you want to get. So Arduino, what they do is they release both, you can buy these boards from them directly. They also release these like architectural plans for these that they upload to the internet, and anyone who wants to manufacture them can make an off-brand one totally legally.
That's pretty
And
cool.
yeah, open source hardware is such an interesting part of electronics culture. I'm a big fan of it. So they make them in different like footprints. So they have ones that are really tiny, like the size of your fingernail, that you can get if you want to make a very, very tiny project. They have really big ones if you want to be doing something that involve a lot of wires and you're running out of space. It depends on what sort of thing you're looking for. This Arduino Uno R3, this Arduino Uno, and I can give a list of this information later if anyone wants to reference it. This is a really good beginner board. It costs, again, like 15 bucks or so. It plugs in through, it's a bit of an archaic USB port, but you can probably get one that has a newer USB. Has a power cord that you can connect to a 9-volt battery. And then it just has these little holes that you can plug wires into. Like, they're called pins. I don't know why they call them pins, but you just plug them in. And then there's a wire that's connected. You don't have to solder. You don't have to touch any solder unless you feel like it. Soldering is a really fun thing to learn how to do, but you don't have to with this.
No. Is that like standard, or is that like does that like limit your applications by not soldering?
Well, it depends. So not having solder is nice because then you can quickly change things around. So you can quickly swap out, I want to have this, I want to have this. And they specifically have these things called solderless breadboards. This is a really tiny one. Oh, I was digging around in the dirt earlier. My fingernails are horrible. This solderless breadboard, it's just a bunch of those little holes that you can plug wires into. For this reason, I would recommend, if you're doing this kind of electronics, avoid the wires that have the multiple strands on them. These are really good if you're working with standard electronics and you want to twist them together. It sucks almost immediately if you start trying to plug it into these.
Yeah.
It just does not work.
So not a great connection. I'm guessing the ones with multiple wires are for when you're going to be using solder. So for a more permanent fixture. And then the pins are definitely easy, like plug and play. And I'm sure you can hot swap or do whatever you need to do on the fly. So the pins are super easy, but they are pretty delicate when they get down to like single pins and stuff. So be careful and make sure you're lined up correctly because nobody likes broken pins.
100%. Yeah, those pins, they can get pretty fiddly. The pro tip I will give that I've never had a problem with, but it's really do at your own caution. I just cover everything in hot glue at the end. And hot glue doesn't conduct electricity. And I just cover it enough until it's like a big ball of hot glue. And then it's basically something you could throw around. Nothing's going to get loose.
And I'm sure there's not enough power running through there to get hot enough to like melt that or do anything. So
generally, no. So yeah, that's
bad.
a good point. This is low voltage. So that's one thing I actually wanted to talk about. These run off 5 volts. So you get those out of, it can handle, I want to say up to like 9.9 volts. So you can run it off a 9-volt battery, but these are low voltage devices. And they run off DC, not off of AC. So you can run them off a battery. If you want to connect them to high power, you want to be running, you can have these control things as much as like, I want to say I once had these switch on and off like vending machines. So actual like AC units, whole like big machines. You just got to get a good enough relay that can connect off to that high power, but this can totally control it.
Cool. So what applications are you using for like in the garden? Is this for irrigation? Is it for lighting? Is it for, I don't know, what, like oscillating fans? Like what do you can use it for everything?
So I'm just starting to use it for this season. I just got everything out today to talk about it before I hooked things up and thought about them in the garden. My intended goal is that I have a cold frame that I'm always messing with. It's always way too hot or way too cold. And I would love to have it so that if the temperature is wrong, I can either kick on a fan. I was also looking into, you can get special kind of motors called servo motors that
Servos.
instead
Yeah.
of just spinning, they can go into certain positions. So if it gets too hot, you could turn on a servo motor that could flip open a window. And then as soon as it gets too cold, it closes the window again.
Yeah. So
So
better
I was
better
thinking about all
articul
those.
yeah, better articulation with servos for sure. Um, yeah, so it sounds like this is like um like a one size fits all like puzzle piece for automation. Is there an easy way to program, or since it's open source, are there a lot of software like people have already written out there for all of these applications that you're trying to use? You don't have to, write any of this stuff yourself. Is that what you were saying at the beginning of this?
So it's a mix. So because you're doing DIY automation for your specific project, people have probably written something that is it is like 99% the same, except maybe they connected it to a slightly different motor, or instead of a light, they connected it to something else, but it's going to be almost exactly the same. So you could very likely go on the internet and find something that is almost exactly what you're looking for, and you just need to customize it a little bit.
Okay.
Or if you really have no idea what to do, if you go onto like Reddit and just ask, someone will be able to help you get anything that you need.
Yeah. So you've brought up this idea of like uploading code. What does that actually mean? Like, all right, I'm looking at this device and I see my computer. How does it plug in? How do I put stuff on it? All that kind of stuff.
That's a good question. So this board has a little chip on it that's a computer. And every computer, when it runs, it has binary code that it looks at and it does some electronic magic with. When we write code on our computer, it's just basically like a Word file that's on our computer. So we've typed it up and we think, okay, theoretically, this should do what I think it should do, but it's just words on a program. In the Arduino editor, which is a program you can download to work with Arduinos, they have a button called compile and upload. And what that does is it takes your whole program, it converts it into a language that computers can understand, basically into binary. And then it uploads it where it sends it through a wire into this connection. So you plug this over USB into your computer, you click compile and upload, it sends it, and then immediately begins running your code in an infinite loop. So it will do all of your instructions that you put again and again and again and again forever.
So that's it. You basically just drag it over, drop it in.
Yep. It's super, super easy. It's so easy that they've made, I often like kids can do this. I've seen kids that are able to do this. And I don't say that in a way that like if you struggle, it's bad. This is just a skill that anyone can learn. It takes a little bit of finagling to figure out, but it's not scary.
Sure,
And
I've spent a few
yeah,
months learning the code. Didn't do anything crazy, but it all builds off of, you start with the binary stuff and build on top of that. And really, it depends on how your brain works. If you're good at writing syntax and like parameters and like stuff like that, it'll come super easy. But some people will look at it and their brain just shuts right off, and that is what it is. But if it's open source, I doubt you'll come across a problem that somebody hasn't already partially addressed or tangentially addressed in figuring out their own thing. So the open source part of it makes it super interesting, and I just love the DIY aspect of it. So with these projects, like how many Arduinos would you need, say, to switch lights on and off for like a home grow or like a basement grow or something like that, just in case I want to use these in the future?
so the way to think about it is how many programs do you need to be running? And then how much effort do you want to be putting into making like a, a, a person who is doing software engineering, who is writing code, could make that entire thing run off of one board. It might be a bit of a headache if you're a bit of a beginner and you're trying to make a whole bunch of stuff happen on one board. It might be easier to have a few considering the low price point. So like one maybe for each stand of plants that have certain conditions you're checking for. But theoretically, you could have this run an entire like building's worth of stuff.
On one
Yeah.
on
So
one board.
yeah, so that
Cool.
answers my question about that I was going to ask about like how much power can these things manage? Like, does that get weighed into like how you would apply them, or is it just simply like it writes the code and then like whatever your power source deals with that, and the amount of power coming through almost doesn't impact it in any way?
Yeah, that's a really good question. It with electronics, they run often in like in an automation setting. People tend to talk about power versus control. There's this idea that there's this power that you run like your car on or your tractor on or your lights on. And control signals are these things that you don't connect to the big battery. You connect the little wires to. And those little wires connect to like a little battery somewhere. So this is all about the control systems, which don't require a lot of power. You can run them for a very long time. And for the sort of applications we're talking about, you're not going to hit into a lot of performance issues
Mhm.
because anytime something reaches into human speed of interaction, like the amount of time it takes for something to be pressed, the amount of time it takes for something to heat up and cool down, that is super, super slow to a computer. So even something that's this cheap, it's still more than enough performance for most applications. So yeah, you don't have to really worry about anything being overpowered. You need to make sure it's got its 9-volt battery that's plugged in, or you connect it to a thing that's connected to the wall. And if you want to connect something that's higher power, you need to have its own isolated power source that again is connected up to a relay that can block that high power from our little baby 5-volt control signal that our Arduino is running on. But it's super, super adaptable. One thing I wanted to bring up is I started taking e-waste I found outside and ripping it apart and actually like harvesting those materials and repurposing them into projects. So I haven't used all of these, but just a few things. Like this is a just a regular motor. I found this in a CD drive, and I realized it just has these 2 wires. It's just a regular DC motor, so that you can build it into a fan. You could do whatever you want with it. I'm trying to see
And
what else.
so on the board, there's no like there's nothing mechanical on the board. There's no, it's all like solid state memory and stuff like that. So it's super light, super like okay. So that I
Yeah,
think I
but
was I was piggybacking on Andy's question about the power drain. There's nothing mechanical going on there, so it is super low voltage. And I guess with what transistors, it's just getting those little seepages of power as it needs it.
exactly.
I
Yeah,
got it.
and I mean the highest probably power draw on this thing is it has an LED. That's probably the most power expensive thing. That and then the CPU chip, but that chip's not doing anything super complicated. If you want to get something that does more, this is another board that I lifted briefly. So this is called the Adafruit Circuit Playground. Um, this is an example of why open source hardware is really cool. So this is not made by Arduino. This is made by a company, I want to say they're in New York, that does their own open source hardware. And they made it so that it runs with anything that you've written in Arduino can work for this. But this was designed specifically for beginners that don't have any experience or background in electronics and want to learn about it. And so instead of pins and soldering, they made it so it's all with alligator clips. So that way you can just hook things up super, super easily. And on here, it comes out of the box with temperature sensors, light sensors. It can produce sound and light. It's got buttons. It's got audio sensors. So if you just get this, you could automatically be doing all sorts of stuff and not even be buying extra parts for this.
And how much does that thing cost?
I want to say it's 20 bucks.
Oh wow. Yeah,
Yeah,
you got
it's
me
super
thinking
affordable.
now. I'm very tempted to go and buy a bunch of those for like mobile chicken tractors and like have them on sensors for the doors and like even feed. You could probably set it up to like scoop feed and stuff like that.
Yep.
This is the reason why technology companies are so profitable. It's because these things are not expensive and they're not difficult. They're just sold for a lot of money.
Well, there's a lot of brain power that goes into it. Like if you can, like you said, if you can get a whole bunch of functionality onto one board, you're doing some pretty serious coding because you're writing all of those parameters, and that code, like you said, it's running for infinity. It gets longer and longer and longer, and that gets pretty complex. So I could definitely see for beginners and for DIY, it might be a better option to get multiple boards and have them set for specific tasks. And then as you get better at coding, you can sort of at some point get a new board and combine all of that onto one. That would be the approach that I would take based off of what we've been talking about here. But the cheap price point is definitely encouraging for people who aren't sure or might be on the fence about using this. It sounds like you might discover something pretty great by mistake if you play around with it. So I'm pretty curious. I definitely want to learn a lot more and get some hands-on experience with it.
If you're willing to get like fiddly with wires and stuff, you can get some of these that come only partially manufactured. And if you manufacture just by soldering things, they just sell it loose. And you can get things down to like, I want to say I've seen some really small, unput together things that are like $1 that still have all the same like brain power in it. It's just like the wires are a bit more complicated. It takes a little bit more effort to get used to, but can do all the same things.
That's cool. So this might be a dumb question. So I mentioned earlier that I have this Bluetooth smart switch, and it came in like a 3-pack or something for like $25 or $30, and like two of them have already died, and now I'm down to just one. Which again, I was like, all right, $25. I got a few years out of them, whatever. But like the way you're talking about this, the Arduino equipment or the board, they're designed to, or at least you infer that they're designed to last. So what is breaking in these switches?
So that's a good question. In a lot of manufactured electronics, it's the more things you shove into something, the more moving parts you have, the more features you're trying to produce. It's just another thing that could break. And if everything is really interconnected and put into a plastic housing and you don't tell people how to fix it, you don't give a manual for repair, as soon as that first thing breaks, the whole thing's dead. So probably what happened was a solder got, like one of the wires got loose maybe, or maybe one of the capacitors broke and something got fried. If I were you, I would actually open one of those up and look inside. If something got burned, you should see it. It's probably got burned black and smells bad. And if it's not that, then nothing got fried. And so it might just be a loose connection. If it's communicating over Bluetooth, it's possible that like the people who manufactured it, if they like misconfigured something, it could be like a software error somewhere. But at a minimum, I would open it up and I would harvest the parts out of there. Like I got over here, I found an office printer on the side of the road, and this is a fully functional Wi-Fi card I found in it. Out of that thing, you can get out the Bluetooth cards, and if you ever feel like learning communications, you could use them. I would not recommend getting into comm stuff because that can get really complicated really quick. You could also sell them or give them away to people who like to use them, but you should definitely get the stuff out of it.
Cool. Yeah, this kind of goes into like the more doomer part of me of like harvesting parts, and like this is a big tangent, but there's this show, The 100. I don't know if you ever watched it, but like the story of it is basically it's like these people came back to Earth after it's been decimated, and like they make such a big point about like harvesting tech, as they call it, which is just like every and any computer they can get their hands on because they can pull out the parts, and like that's like a very fundamental skill that they've been taught in order to survive. And I imagine that's probably one of the things that is going to be much more accurate than we would ever actually predict, because of the fact that there is a lot of this like equipment that we can utilize in different ways, not just necessarily the way it's been put together in a computer, but like as you said, pulling parts out, being like, all right, now I have these parts, how do I utilize them?
They, I found it one of the most sort of technologically radicalizing things I ever watched. I wish I could remember the name of it. It was this guy who was studying the culture of technology in Cuba. Specifically because all of a sudden, all of these products that they depended on being imported into the country stopped being imported. And once things broke, people had to figure out, what on earth am I going to do? And they started figuring out things like if I take the engine, if I take the motor out of my dryer, I can hook it up to my bicycle and then I can get a motorbike. Or if I use this tray that I ate food off of, I can use that instead of an antenna to get radio. And people just started DIYing and figuring this stuff out, and it became a really big part of the culture. And so it can happen quick. As soon as necessity arises, people figure this stuff out.
Sure, and I think that's a key word is necessity. Once a necessity rises, people will figure out how to scavenge what they need if they can't make it, or find substitutes. And the way we've been making electronics for years and years and years is on that curve where technology goes. By the time the next generation comes out, the technology has gone along 3 to 9 times stronger than the previous generation, but they sort of it's the planned obsolescence part of making these things so that they can make a little bit more money and squeeze a little bit few more pennies and dimes out of selling them. By the time the last person buys one, the product is typically obsolete for who I don't even know how long. So I think that's one of the things that's surprising with these boards right here is that they are built to last. But the reason they're built to last like that is because I think it's so simple.
I got this board, I want to say in 2009, 2010. I've covered it in hot glue. It's made to be used. And you connect it to stuff, and sometimes the stuff you connect it to breaks, and then you disconnect it and you connect a thing that works up to it. This thing, it's worth more than $25, and you can get it for less than $25.
Yeah, that's awesome. So in your experience having worked with it, is there any particular application that you've seen or experienced yourself that you're like, this is really outside of the box? And I know we've focused at this point on like gardening, but obviously like people listening are, if you're into gardening, you're probably into more DIY in general. So is there anything in particular that you're like, hey, this is a cool application, or some things to think about maybe you wouldn't have unless you heard about it?
Let me see. People use it in a lot of really cool art projects. A lot of multimedia applications trying to figure out how humans can interact with the world, because you can design all of your own inputs and outputs for things. It's also used a lot in the accessibility hacking community when people realize the technology was not built for their bodies, so they instead build the technology that works for their bodies. People building their own accessible, like just a video game controller. They'll make an Arduino or a Raspberry Pi. They'll take one of these little things and they'll make a device that works for them. That's actually, I would say, one of the coolest parts of DIY electronics is the disability movement that's coming through it.
Yeah, that's cool. It's one of the things that's really cool. It's like one of the only accessible ways for technology to be utilized by people is through stuff like this. In the sense of you don't need if you were to start a company to do something tech related, like you need some money. This you don't. You, like you said, you can just take $100 and you can do a lot.
You'd be spending a lot of time. I think it depends on the software side and the coding, and if because it's open source, if what your specific task you're looking for isn't out there, you're going to be spending a lot of time trying to figure out how to build that code from the ground up. But other than that, like if it's something like truly unique to your situation or whatever you're trying to do, and there isn't a product out there on the market for you, then how invaluable is the thing that you're working on once it's complete? And if it does work, you could have struck gold.
Yeah. And with that in mind, also, if you're working on something and you find that, like sometimes they'll sell boards. Well, for example, here's one example. Arduino, it's designed so that you could put these things called shields on top of them, which look like this. And you just, let me see if I can do it without completely screwing this up. You click them together, and now you have a double board. And this double board has all of the features of your Arduino and then everything that's in your shield. This shield is designed for audio video stuff. So you can play around with video cameras, with feeds, with audio. if you're working with something that is very like specific and you're starting to worry about like, okay, how do I encode video signals into wires, like going like way out there, you can take a look and see if there's something already off the shelf, like a shield that you could pick up and just make that problem go away for yourself. Spend an extra like 20 bucks on it. It'll make your life a lot easier.
So there's my DIY security system right there. Done and done.
Yeah, yeah, I definitely have. I'm like fomenting plans now.
That's
uh,
just it. That's what I find so exciting about this is in that same documentary I was talking about where they talked about the technology of Cuba, the person said it's something like overruling the dominance of the manufactured item. That we've just been accepting that things are built a certain way, but once you realize that you don't have to observe that authority, you can make things do whatever you want them to do, your entire perspective shifts and it goes into this creative mode of there's so many things that I could do, there's so many problems I could fix. And it's one of the most
Absolutely.
exciting ways to engage with technology.
Sure. And who actually reads the warranty anyway? Void that shit. if
yeah,
it's
it's
broke,
very
if it's broken, go in there and figure out how it works, and buy a shittier one and make it better, upgrade it, do something.
yeah, it's very much an emperor wears no clothes situation, where there's this illusion of technical skill and authority over manufactured goods. And with the surplus of materials that's out there, I mean, I think about like my own printer that's upstairs that's broken because like everyone has a home printer and no one's home printer works. Like all of the things that are in it that you could utilize for other uses. Like I have like security cameras for my animals just to keep an eye on what's going on and sensors for lights at certain areas where like where I've had fox attacks or coyote attacks or whatever, just to kind of keep an eye on things. And that stuff isn't cheap, but also like maybe I should have been thinking about doing something like this. And like I said earlier, thinking about automating things like opening and closing chicken coop doors and duck coop doors and all the different things that otherwise would cost a lot of money and usually don't last very long when you buy them off the shelf.
Yeah, absolutely. And the things that do last a while, they tend to be like sometimes when you go to like there's a certain variety of electronic that you know will last basically forever and it was designed to last forever. Like I still have my Game Boy from like the 80s. It still works. Like the
Yeah,
screen's kind of a little wonky, but that's it. And there are times that if you want something to get done a certain way and there's a product that, will last, there will usually be a community around it where people say, you have to get this one. This one's going to work. Stick with that. And then it's really, do you want to make like a shittier version out of stuff around the house? Like the answer could be yes. Maybe it's fun and maybe it's interesting, but the answer might be like, it's my chickens. This is like, I need them to not die. I'm just going to spend a little bit of extra money on the official system.
yeah, yeah. I mean, even in that situation, I'd probably still check on them, but it'd still be cool to just do, especially if it's. I mean, if you have like chickens for livestock or whatever, there are nights you're like, shit, did I do the chickens tonight? Did I lock them up? And it's like 11 o'clock at night. But if it was on a timer, then, or like a light sensor or something, so it was like, oh, the sun is set, it closes the door. Great. Conversely, sometimes my ducks just don't want to go to bed. So you have to like go out there and like chase them up into the coop. So,
I've
both
seen
sides of the
Andy.
coin.
I've seen Andy put multiple ducks in sleeper holds. It's kind of messed up.
Yeah.
They do
Actually,
go to. They do go to sleep though.
yeah. You were here last summer, right? When I had the babies and you had to help me wrangle them.
Yep.
So, fun fact, totally unrelated, but when you get baby chicks and you bring them into like their new coop for like going outside, sometimes they don't take to the new coop right away and they end up finding like a little spot and they'll just like cuddle in or like go into like a little like ball of baby chickens and
It's
you have to like go at
absolutely
night and like
adorable.
harvest them basically. My partner calls it a cuddle puddle because it's just a bunch of chickens all cuddled up.
It's the
Um,
cutest thing ever. You can't see anything but just fur and feet. It's so funny.
yeah, and they're like half awake, so you can just like pick them up. They don't even really care. Ducks doesn't work. Ducks do not do the cuddle puddle. They just get anxious.
Back
The
to automation.
Sorry.
the One thing I just saw someone post in the chat saying Game Boys are a really good way to get into basic electronics. I think are, and there's a big community of people that work with old school video games. I think with electronics, just find something that it feels like you could spend time and not want to like punch something, because you're going to spend a lot of time dealing with problems. And it's same where if you're working in a garden and you're getting really frustrated, there are times like I'm just not going to work that bed anymore because I just get too angry anytime I try. So I'm just going to move my garden over here now. If you're working on a problem that you're not super interested in, you're going to get frustrated and not want to do it. If you're interested in Game Boys, start with Game Boys. If you're interested in doing a DIY chicken coop, start there and just see where it takes you. And remember that there's infinite depth of complexity if you look for it. So there's always going to be complicated things in there, but you don't always have to deal with the complexity. You don't actually have to know binary. You don't have to know any of these things. They're there if you want to, and binary is really interesting, and it's a really cool way to think about numbers and how we encode data. But if you just want a motor to run, you don't need to know binary.
Yeah. So you keep mentioning that there's a community of support. So if somebody's interested in this, they want to buy some of the equipment, or they want like a list of things that you should have if you're getting into this, or even like the fundamentals like of capacitors and things like that, where's the first place you would send someone?
Yeah. So if you happen to be one of the lucky last few people who live near a radio hobby shop, go there and just present yourself to the person working there, and they will give you anything that you need. They will help you with everything.
They will
They
be so
all got
happy to talk to you.
Yeah, there are a few of them out there, and anytime you go in, it's just someone who this is their whole thing, and this is all they want to talk about. This is what they do. They all
Yeah.
got bought up by like Circuit City, and then Circuit City went out of business. So there are very few left out there. If you don't have that, I would recommend going into if you go onto Reddit and you look at like r/Arduino, r/learn to program, just some of those like big category groups, and be forthright and say, I've never done this before. I'm thinking about doing this. Does anyone have any feedback? And you'll get probably 100 too enthusiastic people giving you too much information, which is a good kind of problem to have, is too much information. You can
Yeah.
also, in most communities of like, most of us through one way or another are connected to a person who knows about this stuff. So like for those who go on internet communities, there's probably one or two people that if they don't do coding, they may do like ham radio, they may do something like that, and they can direct you towards things. You might have an uncle who's an electronics engineer. You might have a cousin who got really into Game Boy hacking. Just reach out to your networks and ask a human for help, and humans will help.
And that reminds me to remind people that are listening, if you want to meet some of the folks that are into this stuff in our Discord, that's a really good place to go check out if you're interested in our Discord. Hit us up on Instagram or Facebook or Twitter or whatever, and we'll get you over there so you can talk with some really good folks. Additionally, in terms of places, I think like Elliot, is that place that's off the highway in Central Falls still there?
The radio spot you're talking about?
Yeah, the one that you could always see off the highway that I don't understand how it was ever in business forever.
I haven't driven down that way in so long. I have no idea, but
Well,
I vaguely remember what you're talking about.
yeah. So if for folks that are listening from the Providence area, I think there is I don't remember what it's called. I think it's called like You Fix It or something like that. But it's right off the highway, I think in Central Falls or Pawtucket. So go check them out if they're still there. I hope they are.
I might look it up. I'll go for a drive this weekend.
Yeah, get out
You
there.
can also check out in some areas, it depends on where you are. Some libraries have maker spaces. I would recommend also just looking up and seeing if you live near to a city that has a thing called a maker space. It tends to be just sort of like a carpentry shop, but for electronics. And it's very drop-in, hobby shop, swap ideas, pick through things. Much less common in rural areas, but in rural areas, you tend to also have people that are more familiar with DIY that can hook you up with, oh yeah, that's how I wired that up, But many libraries have now maker studios, and if they don't know how to do stuff, they can connect up with the person who got them the 3D printer or whatever that they don't know how to use, and then that person can tell you how to do things.
Yeah. Cool. Is there anything we didn't ask you that we should have asked you?
I'm thinking. You didn't ask me about things like voltage and resistance and some of those electronics things. And I'm sort of glad you didn't, because I'm not really good at answering them. I definitely lean a bit more on the side of like accidentally blowing things up. But it's something that if you start wiring things together, you're going to have to start paying attention to how much voltage can they take, how much current can they take. And you're going to have to start playing around with things like resistors. Like I have a big one here, I have a little one. These are kind of like little nozzles that you can put on the electricity to kind of slow it down.
Yeah.
They release the power as heat. And so you can pick one that can handle a lot of electricity, a lot of voltage. You can pick ones that choose, have a smaller amount. I am very clearly not an electrical engineer. I did not explain that properly. If you're wiring things up, you should double check if you need to connect something like a resistor or a capacitor in there to protect it. For LEDs, that is especially important.
Yeah.
And if you just ask online, people will usually tell you exactly what to pick up. And the lines on the side of a resistor, those are just numbers that tell you how powerful it is. So that way you never have to remember. You can just plug these into you can get like a little flip card that can tell you exactly how much resistance it can provide.
I've never known how to read those, but it makes sense.
Yeah, you can just get a printout card. You can get it on a little index card. The last thing is if you drag something out of the trash, you'll notice a lot of times they have a bunch of numbers on them. So you'll notice that even inside of your electronics, a lot of them, if you pull them up, have those numbers on them. Those are serial codes that if you plug them into the internet, you can get the data sheet and it will tell you exactly what it is, how it works. It will give you the wiring diagram. It's the best way to go through trash and figure out what's in it and how to repurpose it. So keep an eye out for those tiny little numbers. If you're ever not sure what they are, just start seeing if you can read them and type in anything you see. And eventually you'll probably run across a data sheet explaining what it is.
You're going to turn me into a hoarder. You know this, right?
He's just going to be picking up so much trash. He always picks up trash. Now he's going to be picking up printers.
Yeah, it's usually like, oh, that's a nice branch. I should bring that home.
Right. That's somebody's tree, Andy.
This is a router that I should have thrown away several years ago that I keep being like, oh no, maybe I'll use that heat sink. I better keep this.
So, all right, I got one more question for you. And this is like why I've never got into any of this kind of stuff. And I've tried a million times. How do you learn to read schematics? Like I tried Googling that question a million times and it doesn't give me an answer. So I don't even know how to start figuring out how.
Mm-hmm. So you're talking about like a wiring diagram kind of schematic?
Yeah.
Yeah.
So I feel like that plays into this a bit.
Yeah, for sure. I'm trying to remember. So I'm very much just sort of a beginner at it. The way that I learned was I started. Well, to those of you who aren't familiar with this, all these electronic components, there's a lot of information. And if you just start wiring things together randomly, you're going to get lost. You're not going to know if you did things in the right order. So engineers have made a very formalized way of describing how things are laid out. And the way that it works is that each electronic part has a symbol. And those symbols are connected by lines that indicate if they're wired together. And so what you could do is you could look up what is the symbol for a capacitor? What is the symbol for an LED? What is the symbol for a motor? And each of those symbols is linked together into that diagram, into that schematic.
It's a goddamn flowchart, Andy. Figure it out.
You would think it'd be right up my alley. I just, every time I've tried figuring it out, I'm just like, I'm lost.
It's the language that it's in. You have to speak engineer, basically. So I think there's a lot of I guess like base level knowledge that you have a really good grasp on and understanding before you could look at a schematic and be like, oh, I understand how this works. There's a whole lot that goes in because I mean they still have like the voltage and the power that's running through it is all listed on the line where the parts are connected together, and then yeah, there's just a whole lot that goes into it. I've looked at the schematic for a wiring harness on like a motorcycle once because I was having like blinker issues. My nose started to bleed in like 30 seconds. I was like, I'm not doing this, so I just took it to the shop.
Yeah, they get really dense, but it's because it's sort of like saying, how do you read the all of the financial records for a company? It's like that's a lot of information. It's not really designed to be something that you sit down and read. It's more like a reference or a thing that's encoded there in case you ever need to check something. Um, and it's something that you're trained formally in how do you write this down in a clear and concise way and make sure everything is listed. Um, some of it, though, once you start picking up the little pieces, it gets easier and easier. Like LED stands for light emitting diode. And the symbol in a schematic for that is it's a diode with a bunch of lines coming off of it because it's emitting all that light. Usually, when people make a new part, they try to draw a picture of it. Like a capacitor was originally made by someone figured if you put two metal plates next to each other, eventually, if you made them both full of
Hot.
electricity, they would zap each other. And people basically used it. A lot of electronic components come from like pranks people used to pull on each other with electricity. That was like a zap prank people would do. And so the symbol for it is two straight lines with two lines coming out of it. It looks like two plates. And so even though capacitors don't look that way anymore, that's the symbol for it. It starts with
Yeah.
people drawing what they think it's like, and then over time they modify it. Well, like, oh, this is the kind that like produces light, so I'll add some light coming off of it.
Yeah.
Yeah, and it's
Is
just
that where
it's
the is that where the Bluetooth symbol came from? Because I look at it and I don't get it, but I guess it makes sense now.
I don't even remember what the symbol is. Every so often, people just come up with their own proprietary symbol, and I think it's very silly.
Yeah. Yeah, when I was in high school, I really wanted to fix up this old antique record player that I'd gotten. And it was from like a very first generation.
I
Um,
remember that thing.
yeah. And I was like, I'm going to figure this out. I bought it, so I'm going to fix it. And like, I tore that thing apart, sanded it down. I was like, I've got so much time invested. I'm going to figure out the electronics. And nope. And yeah, every time I tried to figure out a schematic, I was just like, I can't even figure out where to start. Like, how do I Google? There was no Google at the time, but like, how do you search on the internet? Like, this weird shapey thingy. Like, what does that mean? So
It's gotten to a point now where probably if you were to type into like Google, like schematic symbol triangle, they would be able to say, oh, do you mean this? You can go into Google image search. You could try to look there. They also do have some like index pages. If you say like schematics index, that they'll just have all the symbols and names for them. And then sometimes people just come up with their own symbols. They'll put all of the ones like, okay, all of these are capacitors. All of these are blah, blah, blah. What you did notice though, is it does take to entirely reverse engineer someone's whole like life's work of a device is very difficult to the point that very few people are able to do that successfully in my experience. If you're
you
able
make
to
me
do it,
feel better.
it's really hard. I think a lot of us start with that and we're like, oh yeah, totally, I'll just get this and I'll just hack it, I'll figure it out as I go. That's not the way like human brains tend to pick up wisdom and figure things out. It's smaller bite-sized hobby things that you do over time and you build up that wisdom.
Yeah. For people that are watching, if you have any final questions, anything like that, please drop them in the chat. Elliot, do you have any other questions we didn't cover?
Not a question, just a comment. Anybody who's jumping into this, because I have played around with electronics before. I built my computer that it's probably going to explode very soon, and I can't get any parts for it without breaking the bank. Cable management. Learn it, love it, because even if you do get your Arduino working and the software works great, if you have a cable nightmare, you're not going to be happy with it. So that's the last step that people tend to overlook. They just sort of plug everything together and it works, it works. But if you can sort of make your own schematic or label wires and label everything that you can, so that if it does break or if you are upgrading it, it's a lot easier to go in there and fix it rather than untangling a knot and then getting frustrated and building a new one, because that's probably what I'm going to do to my computer.
And with computers, it's not like it is a 30-cent part that you risk breaking if you mess something up.
Right, right. And I only wanted to build it once, put it together twice, but the second time was to clean up all of the cables, and it was a nightmare. So I'm just trying to save everybody some pain. If you are going to be hooking this up and it's a not a simple DIY, think about that ahead of time as you start to connect all of your pieces, and it's going to make your life a lot easier when you get towards the end of your project. So that's my 2 cents.
I had nothing else to add. Charlie, this has been fantastic. I've learned a ton. I feel much more confident about trying some of this stuff without like being a total looking like a fool. So I appreciate that. And I'm sure I'm not the only one.
I'm gonna now build one of those breakfast machine things that makes breakfast and dresses me in the morning, all out of Arduinos. It's gonna be like Pee-wee's Playhouse, but way less creepy, but probably not. Who knows?
Slightly creepy.
So it will
Marginally
be creepy. Yeah. Yep.
Yeah.
A lot of clowns.
A lot of clowns. So thanks so much. Before we wrap up, I'm going to plug our Discord one more time because there are a bunch of really smart folks that are over there using this kind of stuff, as well as peripheral stuff like radio, and there's a lot of good resources over there.
There's a ton of good stuff in there. So get in there, get into the Discord. The link is up. And what did you want to? Oh, I'm sorry. You go ahead, Andy. We're gonna do our thing after.
Yeah, Charlie, any last words before we kick you off?
I would say feel comfortable going into this. You don't have to know how anything works. You don't have to worry about, especially if you're working with this sort of stuff, it's pretty hard to break things in a way that's actually like a catastrophic failure. So feel free to just give things a shot, even if you're not 100% sure about things. And don't feel like you have to know everything. Generally, this whole hobbyist field, people are just excited to talk about it. And no one knows the answers to everything. Everyone's a beginner at some part of this. So just try to have fun with it and learn as you go.
Cool. Thanks so much.
Thank you, Charlie.
All right, so that was fun. I am slightly more qualified to work with electronics. For folks that are watching, if you're not familiar with the Poor Proles Almanac, we are a podcast. We also do this Twitch thing every once in a while. If you jumped on late, we do post all of our Twitch streams, both to YouTube and onto its own separate podcast called the Poor Proles Skillshare. Our traditional podcast is called the Poor Proles Almanac. We are 85 episodes in, maybe more. I'm not 100% sure anymore. We just dropped an episode last night, Maya Milpa Part 2. Tonight or tomorrow, depending on when we get the final edit cut to us, we'll be dropping an interview with Dr. Annabelle Ford, as well as some Mayan farmers in Belize. So that's super cool. If you guys enjoy our podcast, please jump on Patreon, throw us a couple bucks. With Patreon access, you get early access to all of our episodes, usually a week early. We're dropping a ton of episodes, I think 9 and 16 days right now, because we're doing a mini series. So this is kind of an anomaly in terms of early access, but you guys giving us a couple bucks reminds us that people care what we're doing, helps us pay our editors, helps us pay for content hosting and restreaming, which allows us to stream this to all the different places you're watching this right now. And all that stuff costs money. So if you guys can throw us a couple bucks for that, that is fantastic. Supposedly there's this thing called a Prime subscription on Twitch. If you're watching over there, it doesn't cost you any money. If you want to toss that over to us, we would greatly appreciate it. Next week, we are going to be doing, what are we doing next week on this thing? Do you remember?
I knew you were going to ask me that.
Look at that. One step ahead.
I have my calendar up.
Nope,
I lost it. We don't have anything next week.
We do have something next week. It is resizing and repair of clothing. So if you guys are interested in some fundamentals on sewing and stitching,
you need to send me a link, bud. I'm not invited.
I'll get that over to you. I think that's pretty much it. We are Busy me. Oh, and if you join our Patreon, I mentioned the interview with Dr. Annabelle Ford and those Belize Mayan farmers. We are actually releasing, and this is like a one-time only kind of thing. The full video from our interview with the Mayan farmers is up on our Patreon. We generally never put up the video, but it's a really interesting experience. And when the episode comes out, you'll understand why. And that will also be an unedited version of part of that interview. Will be up on our Patreon, but we'll be cutting it significantly for the podcast. And again, that'll make sense when you listen to it. So yeah, we're busy. We got a lot of cool stuff coming up. After that interview, we are doing a whole new series, meeting with a bunch of names you recognize. I can almost guarantee it if you're watching this. So if you haven't listened yet, go jump over there. Any final thoughts, Elliot?
Hats. We got beanies
Oh,
just in time for the spring. Winter is over, but get yourself a spring beanie. They are pretty sweet. They got a nice leather patch on it, and they're kind of like oversized, like statue beanies. So if you got a big dome, you can wrap your head around this thing.
yeah, hell yeah. Those are $23 shipped. Hit us up on Venmo, Cash App, or again, message us on Instagram, and we'll chat about the different ways we can make it work. And of course, we still have stickers and patches and all that good stuff. So if you want some Poor Pro swag, we can hook you
Pro
up.
swag. Get it.
So yeah, help us pay our bills.
And we will keep the content coming regardless. It's been a lot of fun. Always is. Until next time,
Yeah. See you guys. This is Andy.
this is Elliot.
Poor Pro's Almanac.
Peace.
Gotta learn how to hit the right buttons. Here we go.